Thank you everybody for joining today. It's Tuesday, May 19th. My name is Connie. I'll be your host today, and we will be covering the topic GitOps in a hybrid cloud multi-cluster Kubernetes setup. Just a quick intro. As I said, my name is Connie Lin. I am the manager of global events here at Rancher. And our speaker today is ranch hand Chris Carty, who is a certified Kubernetes administrator and also a certified Kubernetes application developer. Chris, would you like to say hello?
Hi, everybody. Thanks for that, Connie. So as Connie mentioned, I'm a collector of Kubernetes certifications. I've been administrator of on-prem Kubernetes installation for the last 2 years and been working with GitOps for probably about the last one. So I'm looking forward to sharing my learnings with you all.
Great, we're excited to have you here, Chris. So before we dive into Chris's presentation, I just wanted to go over a few housekeeping items. Today's masterclass will take probably about 45 to 50 minutes or so. So we'll run through the presentation and then answer some Q&As at the end. If you have questions during the presentation or any time during the webinar, please use the questions tab in your GoToWebinar panel. You can pop in questions there at any time, and then we'll do our best to answer all of them, hopefully, by the end of this class. Quick reminder that this session is being recorded, and we will be sharing the recording along with any reference slides with you all after the event. We'll send the link to the recording, but it'll also be up on our YouTube. So if you do need to step away for a bit or drop off early, don't worry about that. You can come back and access the recording later this week. We also have a masterclass channel on our Slack. So if you have not yet, please hop onto slack.rancher.io, pop in your email, and then you can join the Rancher Slack users channel. There's a masterclass channel and also a couple other good channels for reference on all things Rancher. So today's session is one of our advanced online trainings. It's the Kubernetes masterclass, obviously, but we also have several intro trainings available. If you would like to attend one of those sessions, hop on over to rancher.com/training and you can check out all the different topics we have available there. So with that, I am going to hand it over to Chris, and we can dive right into his presentation today. All right, Chris, I'm going to make you the presenter now.
Thank you, everyone, for showing up today. It's an honor and quite happy and excited to be here. So if I go too fast, I do get a little excited about talking about this kind of stuff. So just drop a question into the chat just to let me slow down, or if I glaze over something, don't hesitate to ask a question. I'll try to get to as many of them as I can. I'll even try to break between the sections just to make sure that I'm covering things off for everybody. So again, if you have any questions, drop them in, big, small, doesn't matter. Hopefully we're all in this to learn something new. So just first question, hey Killix, feel better knowing you're here, buddy. Thanks, hope everything is a-okay with you and yours. And with that, let's get this started. So there we go, with a couple technical hiccups along the way and not being on the right screen. So the agenda today, we're going to quickly go over That's kind of basics, just to make sure we're all on the same page. So we're just going to do a little what is GitOps, just to make sure we all know what we're in for. Then we're going to go into managing deploying workloads with GitOps, and we're going to cover off the multi-tenant model as well as the demo. I have a couple other fun little things sprinkled in there, so we might not stick with it exactly, but this is what I'm aiming to cover today. So, said, what is GitOps? So I think Alexis Richardson covered this pretty good in the initial blog post. I think this was, or the second blog post. So for those of you who don't know, Weaveworks is a company who coined the term GitOps back, it was 3-4 years ago. The anniversary of their proclamation is coming up, so I just can't remember which one it is. But GitOps is a way to do continuous delivery. Works by using Git as your source of truth. So this works for declarative infrastructure, so things like Terraform and in particular Kubernetes files, which really lend themselves to GitOps, which is really exciting from a management point of view and trying to ensure that the state in which is deployed in your clusters is what is in your source of truth, Git. The other thing I'd like to point out is it's not necessarily just Git, it's really in effect source control ops. So if you're still using, or if you are using TFS or Mercurial or something like that, you can still effectively do GitOps, but you may find that the tooling for those source control tools is a little minimal, but it's still effective. You can still do it. So don't be discouraged by the Git part of GitOps. You can do whatever. So before we kind of get into it, I want to kind of describe the scenario I was in when I came to GitOps and how it kind of solved things for us, especially in the multi-cluster scenario. So I was working at a place where we had multiple Git repos, some on-prem, some in the cloud, GitHub, GitLab, kind of all over the place. We had different teams using different CI tools, so Jenkins, GitLab, say it was Circle CI, like any of those. We also had multiple clusters on-prem in the cloud, as well as multiple teams that had their own little workflows. So the problem from our administration side for Kubernetes was we wanted to be able to have a consistent entry method into our clusters, while still at the same time allowing our teams to choose the tools that they needed to get the job done. We didn't want to be overly prescriptive and telling them, no, you can't use Jenkins, you have to use GitLab, or vice versa. So allowing the teams to choose the tools that get the job done, but we wanted to be able to control how things got into our Kubernetes clusters. Again, another thing is we didn't want to be handing out kube config files, worrying about managing those or revoking them. Like, how did we deal with that? Like, we were already using Rancher, so we had some control of how people got access to things. We just didn't want to worry about doing other things and losing control. So started looking around, found a few tools, practice called GitOps, and started looking at that. And the nice thing about that was we really liked the pull aspect of GitOps, where it monitored just a Git repository. It didn't matter where it was, what it was. It just saw changes and applied things to that. So we didn't impact any of the CI aspects of our team. We still let them do what they needed to do with the tools that they were comfortable with doing, and they already knew Git. So we kind of found a nice middle ground there. We allowed them to have their toys, and then we had our common pattern for getting things into Kubernetes. So that gave us our common deployment pattern across all of our clusters, the tool sets, location. We are able to enforce a single source of truth for the for teams who are kind of onboarding. So we got everyone familiar with that. And then we also got flexibility of deployment. So if we wanted to port an on-prem cluster, to the cloud, we could do that quite easily. And to keep things simple for us, we were dealing with most primarily stateless apps or apps that had an external database or external storage, so we didn't have to worry about managing state in that transition. If you're in that scenario, things might get a little funny, but the general pattern will apply. So what we ended up with is something similar to what you're seeing on your screen here. We had developers commit their YAML file to Git, and then from there we'd be able to pull in either the master or dev configuration for the different clusters using the GitOps agent, and then we'd have those clusters in the end be managed by Rancher. So we'd control all of our user access permissions from there. So it was a nice way to do things. So we had a good integration with our on-prem auth systems, and then we had the flexibility for the devs. So while I'm going to be talking primarily about Flux today, I did want to highlight a few other GitOps tools. Flux fit really well for our use case, but depending on your use case, you may find one of the other tools more advantageous. Both Argo and Flux are in the CNCF. Argo came from Intuit, Flux from Weaveworks. Argo is an incubating project for Flux's sandbox, but they're also working on a common GitOps operator or tooling. So they're working quite closely together. And then over in this continuous delivery foundation, you have Jenkins X. So if teams are familiar with Jenkins, that's also a great choice. So do feel free to evaluate whichever one that you evaluate all three, figure out which one fits for your scenario. But common GitOps patterns I'm going to be going through apply to all three. So I just get that out of the way. And then for managing Rancher, one of the nice things that I've come across is they have some really nice Terraform providers. You have the Rancher 2 Terraform provider and their RKE tool. So you'd use RKE to provision your Kubernetes clusters, and then you'd use Rancher 2 to manage your Rancher install itself. So a combination of these sets of tooling, you come up with a very nice automated way of managing Rancher as well as delivering your Kubernetes YAML files. So like I said, we're going to be focusing on Flux CD today. So I wanted to just kind of give an overview of what that does and how we're going to be using it. So Flux, like I said, it's by a company called Weaveworks, CNCF incubating project. And one of the things that attracted me to it was it's quite lightweight, so it doesn't have the GUI, it doesn't have a lot of like extra things that some people would be looking for, but in its lightweightness, it's very flexible and it can be used in a lot of different scenarios. It also has the ability, and this is quite neat for dev and QA scenarios, where it will detect new images being pushed to your container registry. And it will see that and then update your YAML file in Git with the new tag, so you can effectively have an automated release cycle every time a container gets pushed to your registry. Depending on the maturity of your processes, you may not want to do that for prod, but if you're really comfortable with your CI, that would be an option. And you also have the ability to use kubectl or kubectl, and as well as Kustomize built right in. So that's really neat. And they've also built a tool called, we'll go over this one a little bit later, but the Helm Operator. So this is their CRD for controlling Helm releases in a GitOps style, which is very, very spiffy. We'll do a release with that a little later. So effectively, this is what your scenario looks like if you're using Flux. It'll see new container images, pull them down, and then it'll look at your Git repository and just kind of do the default is 5 minutes. So it'll pull every 5 minutes and do kube apply. And so if someone does manually change an in-flight manifest, every 5 minutes that'll get overwritten by whatever is in Git. So it's a nice way of ensuring that what is in Git is actually being deployed. And if there's been any drift, it will go back and correct that drift. So it's kind of a wall of text. I should have trimmed it down, but it is what it is. So the Helm Operator, it is a CRD that allows you to release Helm. So it was up until they just had their 1.0 release a few weeks back, last month, which included really support for Helm 3. So no more tiller in the Helm Operator, which is fantastic. And the other nice thing about this is it doesn't strictly require Flux. So if you're using Jenkins or Argo or hand applying things, you can still use the Helm operator, which is really nice. And this is what a Helm release looks like. So more or less what it is, again, just a CRD. So up top you have your descriptors. So your kind will be a Helm release, and the chart here will just declare where the repository is, what version, and the name. And then down here you'll just have your standard YAML, so your values information that you'd use with your typical Helm values file. So this is just the top half of the Rancher Rancher values file. All right, before I go further, does anyone have any questions? Just give a minute and take a sip. Yeah, okay. No, you don't need a Helm repository. It's just for the Flux operator. So when you add a repo to Helm, so we do Helm repo add. So if you're using something like it's like Rancher. When you go through the install, you have to do Helm repo add, and then wherever the Rancher file or Helm repo is. So that's the only time you'd need that. Flux itself is just looking for a Git repo. So if you're using a Helm release file, you just have that in a single Git repo, and it would run a kube apply to that. And so Flux is decoupled from that.
Hey, Chris. Yeah, it looks like we have a couple more questions here.
I saw that one. Yeah, so I'll answer the quicker one. So the Helm operator does support Helm 3. And I'll show you how that, I have a configuration file for that, so it'll show you how to configure that. And for secret management, there's a bunch of different options. It depends on the team. Generally, things like Vault, or if you're in the cloud, using the key management solutions that Google, AWS, and Azure provide. So it depends on your team choice. As long as it supports Kubernetes, it's normally A-OK. It can use those just like you would if you're running kube apply. There is a tool, I can't remember what it's called, it's by Bitnami, but it allows you to store secrets within Git. So that would be another way to do it, but you have to have a cluster that is pre-existing with the secret CRD that's already there. So it depends on what your use case is. It's the short story of it at that point. But yeah, secrets are always an interesting area. Typically, you'd want to lean on something like Vault, which has a lot of community support. And let's see, apply to the answer. Yeah. Yeah, and the Flux footprint, it's not very big. I don't know the requirements off the top of my head, but I believe one of the YAML files I'll be pulling up later has the restrictions on it, so we can take a look at it then, but it's quite light. Okay. Right, so I think we'll kind of move on. And
yep,
so, yeah,
mm-hmm. So
in one of the areas when first introducing GitOps to different developers is how do you manage code? Do you have a single repository, or for both your application code as well as your YAML manifests? And typically within the scenario, you want to have one for each. There are situations, depending on how you want to manage things, where you can do one repo effectively. But the reason you want to generally split them out into two repos is the different lifecycle requirements of both Kubernetes YAML as well as your application. So when you probably already know this, so sorry if you, yeah, so this might be boring for some people or obvious. When you're building an app, at least in Kubernetes land, your end goal is to create a container, right? So if you're making a change to the YAML file, you don't necessarily want to trigger a build for a new container, as there's concerns are different. So I would say, yeah, so this is kind of it. So when you're an app dev, you just want to get a container. An operator, you just want to change things in the application or the YAML manifest. So kind of have the app dev and then the operator repo. So I just kind of run over that. So yeah, with the app dev, you want to run your unit test, security, dependency checks, all those fun things before getting that final artifact. And the operator side, where I've been having a lot of fun, you want to generally just make sure the manifest is good. The application works when it's deployed into Kubernetes. So here you can do a lot of really cool things, especially around the security and policy front. So using things like Open Policy Agent with conf-test, as well as kubeval, so kubeval, for those of you who don't know, will just make sure that your YAML file is compliant with the API. So if you have a typo or anything in there, it catches it. So as you make commits to your YAML files, you can catch that. And the next phase would be running a conf test, which allows you to apply OPA Rego policy against your YAML file. So again, this is all in CI, so you don't need to wait for you to wait to try to hit the Kubernetes API and have something like Gatekeeper or OPA at that point tell you, no, you're in denial of policy ABC. You can get that feedback within your CI. And one of the fancier steps that I've seen, you can probably do this a few different ways, but is using Kind. So for those of you who don't know, Kind is Kubernetes and Docker. So it spins up a Kubernetes cluster within Docker. So you can run that within your CI pipeline in a GitHub or GitLab. So spin that up, then you can apply your Kubernetes YAML to that Kind cluster, run end-to-end unit tests, things like that against it. So by the time you actually get to deploying to, or that final state on a PR, you know whether or not the application YAML that you've just submitted can actually run in a specific version of Kubernetes with your policies in place, which I think is very, very cool and very powerful, especially if you're worried about maintaining compliance or you have those kinds of concerns. Probably a little overkill for individual developers, just want to get things done, but for those people who have compliance or regulatory issues, who want to do gating releases, that's really great stuff to get the feedback in CI before it hits a cluster, especially a prod cluster.
Hey, Chris,
And then there's the map. Yep.
we have a question here just on your last slide, and ask what is Confest used for?
Oh, yeah, sorry, I might have glazed over that. Conf test lets you run open policy or Rego files. So for people who aren't familiar, so Open Policy Agent is essentially policy as code. It lets you write, say, a policy, like a basic one would be, don't allow anything that has the latest tag, or within X cluster, you can only have image tags that, match a specific pattern, so prod, or you want to ensure that you're only using an internal load balancer on your ingress or your service files, things like that. So you can codify those policies and have them stored within a Git repo. Conf-test just allows you to run those policies within your CI or locally on your desktop, instead of having to rely on OPA running in your cluster with where it inspects your YAML files with a validating admission webhook. So it pulls it out of there, so you don't need to wait for the feedback after you hit kube apply, and then it kicks you back saying you're in violation of X policy. So it's a really neat tool. It just actually got merged into the Open Policy Agent project proper just last week. So if anyone from that team is here, awesome work. So hopefully that answered that question.
Great,
If I didn't, just let me know. Yeah. Okay. So back to kind of this slide here. So typically you want to, when you're setting up your repo, there's different ways you can do this. And just to kind of handle the multi-cluster aspect is you generally want to have a mapping of branch to environment. So a master branch would be the equivalent of your production cluster. Pre-prod would be, your pre-prod cluster. Your naming convention for your branches can be whatever you want, but for a multi-cluster kind of scenario and with different environments, you'd probably want to line up your environments with branches. You could, if you have, say, a failover cluster that was always supposed to be in sync with master, you could have two clusters syncing back to a master, one of those branches. So if one goes down, they're always in the same state, which, again, this is really helpful for, say, transitioning from an on-prem cluster to a cloud cluster or between cloud providers, or having something set up for standby that is going to be up to date within 5 minutes of the last push, which I think is, when that dawned on me a few months back was, I was like, oh yeah, I got all this, this fun data recovery kind of built in, which is really cool. Sorry, I just got out of my slide here. So now I'm going to switch over to demo, or just to kind of show just a quick deployment, and then I'll bounce back to the slides for the multi-cluster slide. Before I go forward with the demo, does anyone else have any other questions? All right.
I don't see any at this time, so.
Yeah. Okay, so this is kind of what we're aiming for right here. So we're going to have 2 Git repos. We're going to have a single rancher instance, and then we're going to line up with a couple clusters just to kind of show you. And I'm going to do that using Terraform with a pre-existing rancher cluster and 2 new GKE clusters. So I'll just bounce over to the pre-existing rancher cluster or deployment, and just going to explain how this one got here. So this is being deployed and managed by the Helm Release object that I was telling you about. So over here we have, so you can see all of our fun things. We have our cert manager, got rancher set up. We also have Flux over here. So I'm just going to move that to the default namespace so we can take a look at it. And hopefully the demo gods are on my side today. Okay, so within the Flux namespace, we have a couple little objects here. So we have our Flux agent, we have our Helm Operator, and then memcached. Memcached essentially just stores the metadata for the Docker containers. So if it's doing auto deployments, that's where that information would be stored. So for the question earlier about the resource usage, so we're talking about a memory reservation of 64 megabytes and a CPU reservation of 50, was it? Yeah, very, very small amount, so 50 milli-CPUs. So let's go back here. And then the Helm operator, I think it requires a little bit more, so it's about the same. So the impact to your cluster isn't going to be a lot. It does add up in the multi-tenant scenario, and I'll go over that in a little bit. So I just want to show you the logs here. So again, this is looping through. You can see all the wonderful output. So you see here, we're doing cert manager 3, no changes. So it doesn't have anything to do. So it just leaves it alone. If it did detect changes, it would do a Helm upgrade or update, which is pretty neat. And the initial intake would be Flux. So Flux would do make the kube apply changes when it got a new any updated YAML. So you can see here, kube apply. So it took 705 milliseconds, and it's applying stuff to the cattle namespace. And you can see it's not changing anything. So it's doing exactly what we expect, which is awesome. And I'll just switch over to the YAML so you can actually see what it looks like. So actually, so this is the Flux patch here. So I'm using Kustomize to do all this. So the base of the base Flux manifest is here in their repo. And then I'm just applying, I would be explaining it. So for those of you who don't know what Kustomize is, you're essentially able to take like small chunks of code and just patch over the initial manifest. So it's really nice if you're doing some custom stuff, but only doing some light modifications. So you don't have to manage full YAML files, just small bits, and you don't have to go all the way over and making your own Helm chart. So it's really nice for that purpose. And for what we're doing today, it's quite fantastic. So we can see here, we're just passing some new args. We're updating just a few things within the deployment, and we're pointing at this repo here. We didn't specify git path, so it's going to assume anything that's in the root directory is fair game. We're telling it it's only read-only, and we're not going to be scanning any registries. And so that repo is right here. So we have our deploy, and in here we have a customization file. It's saying, hey, do cert manager and rancher. And then here for this root of the directory, it's saying hit the Helm operator and deploy. So the Helm operator is our CRD for the Helm operator. Again, it's just pulling from the main Helm operator YAML repo. And here we're overlaying the patch to enable just Helm 3, as we don't want to deal with Tiller, at least not in this scenario. Cert manager, we have our cert manager CRD. So if you go through the rancher install process, you're going to find it all this kind of written out, but I've just put it into a YAML manifest, or put it into this repo here. So it's repeatable, which is really nice. So if you make any changes, it gets captured within Git and then applied. So you have a lot of accountability, and you don't have people, oh, I did a Helm update on the last version and have to do a manual rollback. You can see it all through here. And then here's our rancher Helm release that I alluded to earlier. So I'm not doing anything weird here. So we're still adding the little, I guess I didn't update that here. Or I haven't pushed this change. So this, if you put auto, or if this was actually false, it wouldn't add that local cluster like I'm in right now. And putting my host name here. So there's our typical ingress things. For TLS, I'm using Let's Encrypt. Oh, what I like about using this, it's a lot cleaner than using the flags like what's in their install. I've only used this within dev instances, and it's worked really well. So that's what that is there. And the fun thing that I wanted to go over was the Terraform aspect, at least with Rancher 2. I'm kind of switching gears here from Flux to the Terraform GitOps pattern. So I have a GKE cluster. Nothing too fancy, just one node right now, and we'll update that to 2. Oops, keep that on 1 because that's the initial cluster that gets destroyed. So I'll bring this down to 1 here just so I can trigger a change. So and 1, standard 2, so 2 CPUs, nothing fancy. And this is where the fun bit comes in. So I have the Rancher 2 provider here. So we're saying that the Rancher server can be found at this address. I've already pre-provisioned the access key as well as the secret key. And I'm actually just going to get rid of this project. Yeah. So fun thing that I found out the other day. So you can provision projects using Rancher 2, but being that when we import this, the cluster doesn't exist in Rancher right away. So those projects will cause the Terraform script to fail. It's just a kind of chicken and egg kind of situation. So here we're going to output the registration token, and that's pretty spiffy. So that'll be the, sorry, down here, we're going to write the apply command to a text file. So when you do in Rancher, so I'll go back here. When you want to add a new cluster, as probably most of you have seen this before, when you do the create cluster, it gives you this lovely kubeapply command. That file will contain that command. So I'm just going to delete this here. And I'm going to go back. So we've saved that. Just going to go back to my right terminal. This is where I am hoping I didn't anger any of the demo gods. So let's go GKE M count. And if anyone has any questions at this point, this takes a few minutes. Feel free to drop them in to the channel. So this will take a little bit to spin up. So I'll just go over here and just show you what's happening within our GitHub. So I set up a GitHub action to do this. You see, it's been a little bit since I've had an error. So I can show you what's going on in there. So you can use, if you're comfy with Circle CI, Azure DevOps, Cloud Build, or GitLab, the process is generally the same. Just the tool is going to be a little bit different. So here we're just running a series of Terraform steps. So init, validate, plan, and then finally apply. And then the final step here is I'm grabbing that file that's produced at the last step in the Terraform well, I showed you earlier. So I can pass this back and forth. And then I have for a second stage, it's, so I got this from, there's a nice Google demo on how to use the gcloud command in Git as a GitHub action. So that's where I got this from. Probably should have left a link. So it's just going to run your gcloud provider. I've provided a service key for that. And it's going to consume that command file and run the apply. So this is all happening in the background, which is pretty spiffy. So if I go back to Rancher, you can see that it's already created my new cluster and it's just waiting for it to be imported, which when I found out how to do that, when I first started playing around with this was quite powerful because I had never at that point figured out how to automate cluster creation and then add it into Rancher. This really solved that issue. So it became very a hands-off affair, which is super awesome. So let's go back here just to check on our, so here we are just doing the apply. If I go over here to my console, hopefully it will be creating. So hope everyone's got their fingers crossed like I do. And there it is. So it's starting to create now, which is expected. So it's still got the, so when I initially provision this, it's a cluster of just one CPU, and then it adds a node pool and then shuts down the that initial CPU or initial node. So that's how that works. And if I go back to my cluster here, I can do the exact same thing. So I'm just going to make sure. What am I doing here? Oh, that's going to fail. So I got to do a live fail for you. So I didn't update, remove those projects in the Git from the Terraform file. So I got to display what I was warning about. So the cluster will create A-OK, and this part here will take no time. So I flew too close to the sun. So I was going to show you here. So I switch over to my dev branch, and then I have my configuration file for the dev instance. So if I go over here, so I already have this commented out, which is great. And then I can go over here to GKE. You can see dev cluster. So we'll change its node count to 2. Status, add. And this will go a lot smoother. There we go. So that will pop up there as a dev instance pretty soon. So that's that kind of flow. So you can control pretty well everything through your Git manifest, which is, again, a fantastic way to know what's going on, who's changed things. And security teams really enjoy that. And then if you need any auditing, who changed what when, you can well, you don't want to blame anyone, but you can identify where things went wrong or where bugs or misconfiguration was introduced to your environment. Let's go back here, just check on things. So it's still waiting for that initial cluster to come up. Let's go back here to actions. So this one's going to fail because there's a lock on this state file. And then this cluster here is starting to go. Yeah. So I'll let those kind of sit for the next few minutes. Here we go. Here's our dev cluster. So it just takes a little bit of time for things to get going. So while that is going and getting set up, we'll go over the multi-cluster setup. Before I do that, are there any questions so far?
Yeah, I think there's one here related to this. It asks, is the Rancher container, will that be installed in the same Kubernetes cluster or on a separate VM?
Could I get a little more elaboration on that one? The Rancher, so the Rancher cluster is its own independent cluster. The only thing that gets installed into the GKE, say the one that's spinning up right now, is there are a series of tools that talk back to the main Rancher cluster. So they're more or less independent of the main Rancher install. So let's say something bad happens to your main Rancher cluster. So the control plane I'm looking at right now, your clusters themselves are independent of that, so they can still operate by themselves. So if there were things being served up on those, they would still remain serving, even if your main Rancher cluster would, say, go away or say it lost a connection there. You'd notice a bunch of error logs within the components, but that would be about the end of it. So once one of these is up and running, I'll show you what's happening in there. Okay.
We do have one more question from Dimitri. He asks, is this workflow more suitable for infrastructure deployment, cluster deployments versus service or apps?
The model is mostly the same. As you're more or less you're making changes on the code within your repo. Infrastructure, you want to be a little bit more careful, just because things, especially compared to dealing with the Kubernetes manifest, are a lot. Things are easier or harder to walk back from when you're dealing with infrastructure bits. Kubernetes YAMLs are quite easy to change, overwrite, and go back. So infrastructure stuff, I would say, needs to be a little bit more purposeful. You probably want to have a few more checks in it. What I was doing before with when I was running in GitLab is the first 3 steps. So the init validate and plan would be automatic, but then there would be a manual pause step there, so you could review the plan file before someone would press the merge button on the prod or the final apply step. So just to have a little bit more overview there, so you didn't accidentally change things. I would say Kubernetes YAMLs are, you still probably want something like that within your within prod, so that kind of manual review gating process. But for dev and QA, I would still want that with the infrastructure components, but for Kubernetes YAML, go for it, because a rollback is quite easy to do. You wouldn't have to build something from scratch if you, say, accidentally blew something away.
Great, thank you. I think we can keep going.
Okay, so I'm just going to get this guy to rerun. So you can let's go ahead over here. So both our clusters are ready, and this one should be applying now. Okay, so back to our demo. So prevent. Yeah, so here's our multi-tenant step. So as I was showing you or going over earlier, there's the one Flux agent that's doing the sync. The problem, or not necessarily the problem with that, but when you're dealing with a multi-tenant scenario, having, again, this depends on how your org is set up, having one agent or having everyone interact with one Git repo and then one Flux agent can lead to just workflow overlap, right? You could, so just, it depends on how you want to delegate things. The multi-tenant model that the Flux team developed, you have, and what I really like, because it helps sandbox in different teams to a namespace or a group of namespaces. So there'll be two kind of classifications of Flux agent. You'll have one that manages your cluster level objects, so your namespaces, your cluster role bindings, CRDs, things like that. And then you'll have kind of team level or group level agents that are backed into having write permission at only namespace level objects. So deployments, pods, secrets, those things. So if they were to try to add a new namespace with XYZ tool or elevate the privileges with RBAC and somewhere else, they would not be allowed to do that, which is really nice from at least from my perspective as a cluster admin, because then you can give the teams kind of their own sandbox or area of responsibility. So team A comes to you, well, we're doing an app, we need these resources and these three namespaces. You can set up a Flux agent that will do that for them, and then they have, you'll tell that Flux agent to point to wherever the repository is, and then they can do what they need to do, but you still have within your control the pod security policies, the gatekeeper policies, the resource limits. So you have, from a cluster management point of view, you still have all those tools and controls, and you don't have to worry about different teams trying to overextend or do something they're not supposed to, which again, from an admin point of view is really awesome, and hopefully gives the teams the sandbox that they need to do to get the job done. So this is the diagram from the Flux team in terms of kind of just to help illustrate it. So the top row there, you have your cluster admin. So you have a central repo for the state of the cluster. And then each team would have their own little repo and their Flux agent that lines up to that. And now for the demo. So hopefully everything is ready over here. There we go. So our master is now up and running. So, accidentally did that. So everything, so someone was asking earlier about the rancher, what gets installed there. So hopefully this goes away. So down here, so we have the cattle system. So you have a little agent, these two agents here, and those are the bits that talk back to rancher and instruct. So there's a bunch of, I can't remember which ones they're Googles and which ones are ranchers. So you've installed a few different things, but these are the ones that do the communication. So if communication to head office was severed, you get errors from these two, but everything would still operate as expected. You can see here, I thought I had this disabled, but I didn't, so I'll just go over and cover this off. So we have this little toggle here. I guess I didn't commit that part. It should be set to true, and that's what installed this. So that's our Prometheus operator for the cluster. And if you go back here to the master, So you can see all of our monitoring is there. So you can control that from Git as well. So Rancher has a lot of different plugins, and it also lets you install from their catalog. So if you have, so again, you can move things into states. So instead of having somebody clicking through the Rancher UI and installing something from apps, the app catalog, you can do that from Terraform as well. So you get things a little bit more, or you move things more to that declarative state instead of, well, I'm going to deploy, say, grab one of these chart museum in my cluster. If that cluster went away or something happened to it, you want to get back to the known state. Having everything Terraform and Git, really helps that, so you don't need to remember what was installed with what configurations, and yeah, so that's quite powerful. So now that that's up and running, I can show you what the provider looks like, or sorry, the multi-tenant system looks like. So here is the folder. So how you have it set up can be up to your own. This is how the Flux team has theirs set up. So we have a base. Again, this is using Kustomize. So here's our default. So this is what's going to get patched over for every Flux agent that gets installed. So we have Prometheus scraping set up, all the fun things that you don't need to be aware of when you're deploying things. So that's there. We have a git key config. So even this at a cluster level can be boxed into specific roles, which is really nice. And then down here we have the install, and this is going to install the master agent. And so you can see here, this is the Flux patch, which just overlays some extra things on top of what you saw there. So it's only exposes a little bit, so you don't need to be managing multiple really long YAML files, which is nice. So for here, we're telling it that everything that you're going to be syncing with is in the cluster directory. So that would be right here, and this is the repo, and it's going to poll every 2 minutes. So those are toggles that are available to you, and our branch is going to be at master. So if you look over here at cluster, and what these essentially translate into is teams or kind of buckets. So we have a team one directory here. This can be, I think this is just the demo, and I haven't changed this at all. So this is just basic. So there's your org team, and or the org or the team's repo that things would be synced up against. I've broken this one up into a few different slots. So we have a repo for Falco. So I have the configuration for the Falco Helm chart here. I'm going to skip over Elasticsearch, but you can see I have a bunch of things in there for it. I also have a basic web app in here, Gatekeeper, same thing, where I have, it's pointing off to a separate repository where I keep those manifests, as well as the policy that we want to apply. And this is another neat area where you can, where different teams have kind of cluster-wide concerns. So say security and networking teams, they have their own, they want their own input. So you could have, security policies with Gatekeeper and OPA within their own repo. They collaborate with the teams that are needed on that there, and they don't have, no one has to be exposed to the greater cluster. You can just focus on what's there. Same thing can be applied for network policies. So if you're using something like Calico or Cilium, you could have those network policies in their own repo against it. And the teams that are responsible for the network policies and just make the changes in that one repo, and they get synced across. And then again, going forward to the multi-cluster bit, if there were different branches per repo, or different branches equated different clusters or different environments, they'd be able to, from just that one repo, be able to change or control the network policies or security policies across entire fleet from a single source, without having to worry about going to each individual cluster or environment and changing things there. So that's kind of where the GitOps power really comes in. It's just having that single source of truth and then being able to apply it across lots of different environments. So let's get this up and running. So just to show that there's not too much magic here. I just wrote a little script to kind of clear off some things. When you first deploy Flux, it has a pre-generated SSH key. So you can either roll with that or you can supply your own. In this case, I'm supplying my own, so I don't have to on the fly today do SSH keygen or copy and paste an SSH key over the World Wide Web. So hopefully, again, fingers crossed, everything works as expected. And let's do this. So I'm just gonna make sure I'm in the right directory. Get my cluster credentials. And we'll just ignore that. Okay, get notes. And while I'm doing this, are there any questions that anyone may have?
I don't see any at this time, Chris.
Awesome. Okay. So here we go. So everything's being applied. And this bit here, you can have within your CI. So like in the Rancher, the cluster creation and add step, I had that manual process where it ran the command. This bit here can be in a CI process like that. I just don't have it there just so I can better demonstrate that today and have a little bit more flexibility with you. So I'm going to move this over to, actually, let's go back. Yeah. So that the project that I deleted earlier here. So let's go over to Rancher. So now that the cluster actually exists, I can use this. Bid projects. Pushes to master. Cool. So that'll just take a minute to come through. So everything's being deployed there. So it's on like a 5-minute loop. So I'm just going to run that again just to kind of give it a kick in the little nudge in the right direction. And then we should just go check in on our, oops. That should be all done. There we go. Let's see where you're at. Just going to do the plan. There we go. We're applying. So this won't take as long because we're not applying any changes to the cluster itself. So if we go back here, so here's all the new repositories that I had. And then we also have our projects here. So I'm just going to put these in those projects. And this one here, and then we'll put these ones in our demo app project. And you can also set the resource limits for the projects from the Rancher 2 provider. I just didn't want to go into that detail today and add more risk of things exploding. So we're already running out of resources within this cluster. I mean, that's one node. So the Helm operator tried to come up, but it can't. So I'll go back here to GKE and we'll just add a new node. Let's see if I can spell Git right. -m priest. And there we go. So once that new node gets added, it should be a couple minutes. Everything will kind of light up, or that will light up. So in the meantime, everything else is kind of sitting here. So the namespaces have been created by that master Flux agent along with the individual Flux agents for each project or namespace in this case. And so in order for them to be able to sync with their respective repositories, so right now Flux comes up, say this is the repository that I want to go to. It's not ready to sync yet. So when it's ready to sync, it'll fail because it doesn't have the right SSH key. So we'll just give that a nudge. Again, I wrote a little script that goes through and it does that for me. So change keys. So let's go through and delete the key secret every namespace. So like that's something that if you're using a key management tool like say Vault or CyberArk or Google Key Store or Azure, what they're using, you can offload this responsibility to that and have things there, and then you don't have to worry about manually managing things. This is where using the Benami tool, I've bumped my head up against, just because you need a cluster to pre-exist. So you have to do a bunch of different things ahead of time. But you know, that may fit your use case. I just need to spend more time with it. Okay, and here we go. So Gatekeeper's coming up. My little Hello World application is also coming up. Falco might take a little bit just because of the dependency on the Flux, the Helm Operator. And then this agent here, you're not going to see any container come up just because it's syncing against or it's just looking for OPA policies. So if I go here, hasn't started syncing yet, but it's just looking for a CRD, so it's not going to come up with another agent like these guys are here. These folks are here. Any questions there?
Yeah, we did have one question here. It asks, is there any configuration to link the Flux CD with the namespaces? And how do you configure the RBAC for Flux CD in the namespace?
Yeah, so thanks for asking. I completely glossed over that. So when you're in here, so I'll just do the demo app. So you can see we have our PSP or pod security policy, and that's going to be for this namespace here. So everything you want at the cluster level can be applied within this grouping. You identify the namespace, really helpful with Kustomize here, where you can just, anything that gets applied that has the namespace flag just gets overridden with whatever namespace string you have here. The other way that this helps is with Flux, you have the K-It's allowed namespace flag. So you can box things in with the RBAC policies for the Flux agent, as well as within telling Flux itself that this is the only namespace or namespaces that you have access to. So if this were allowed multiple namespaces, it's just a comma separated string. But the RBAC here, so there's a service account that gets created for each Flux agent, and then you just bind the, where is it? Role binding here to it. So you box things in at the service account level, and then again with this flag just to be extra certain. So if you made a mistake and gave it cluster-wide access, you're still telling Flux that no, you can only write to things within this namespace. And okay, so that's all coming up, but so that's it for the demo. Like I've covered everything I wanted to show today. And let's get back to the slide. So before I kind of end things up, any more questions or things I may have left a mystery?
I think there was a question here about why you choose to use Kustomize, not Helm.
Oh, yeah. So Helm, I really like using when it's I'm grabbing prepackaged things, like I'm installing Falco through Helm and Rancher through Helm. So it's a great way to consume other people's projects. And you can install Flux and the Helm Operator through Helm. I just like the flexibility that that Kustomize gives me for this application, for this scenario. I like having a little bit more control over the YAML, a little bit more, instead of having things hidden away with a chart. So it really just depends on what your workflow is and what you're trying to achieve. The two tools are both awesome for what they're designed for, and I think they can happily live or coexist together.
Great. Thanks for sharing, Chris.
My pleasure.
Yep.
Yeah, so if you have any other questions or anything comes to you in the middle of the night, feel to find me around the web at Macintosh Prime, Twitter, Rancher Slack, Kubernetes Slack. I'm there. GitHub is Carty C. I will also be putting all the source code that you see here at that repo for everyone to grab, along with the slides for anyone to review.
Great. Thank you so much, Chris. This was great information today. Appreciate you taking the time, and all of the attendees as well for sticking around. As I mentioned earlier on, this session was recorded, so we will be sharing the recording along with the slides. And for those of you who are available tomorrow, we do have another masterclass at 4 p.m. So feel free to head over to rancher.com/training and sign up there. With that, Chris, did you have anything else to add before we wrap up?
No, just thank you everyone for coming out and listening, watching this presentation. That means a lot. I hope you got something from this. And again, if you have any questions or you just want to chat, feel free to reach out. I'm always happy to talk.
Great. Thanks again, Chris. I hope everybody has a great evening.